Deep beneath the frozen waves of the North Atlantic, a silent chess match is reaching a critical tipping point, exposing NATO communication lines to catastrophic sabotage. In response, the United Kingdom Royal Air Force P-8A Poseidon fleet is executing an aggressive defense strategy to protect critical infrastructure. In mid-2026, the United Kingdom Ministry of Defense initiated air carriage and jettison trials to integrate the highly advanced Stingray modification, one lightweight torpedo, onto their sub-hunters. This strategic pivot means the British Maritime Patrol Fleet is no longer entirely dependent on the American Mark 54 torpedo supply chain. Leading global defense analysts argue that, in a total war scenario, establishing a sovereign weapon solution is the only tactical salvation to prevent the United Kingdom from becoming completely defenseless. A decade after retiring the Nimrod fleet, London finally possesses an unyielding shield. The integration of the British-built BAE Systems torpedo onto a Boeing platform represents a technological triumph. The P-8A Poseidon MRA1 relies on the Raytheon APY10 radar system, which can isolate a tiny periscope from a distance of dozens of nautical miles amidst heavy sea clutter. Combined with an expansive multi-static sonobuoy network, the aircraft forces even the quietest modern Russian submarines, like the Yasen and Akula classes, into an incredibly vulnerable position. Once detected, the target faces the Stingray Modification 1, which measures 330 millimeters in diameter and weighs 267 kilograms. Powered by a magnesium silver chloride seawater battery, its pump jet propulsion drives the weapon past 45 knots to depths of 800 meters. Its digital sonar brain completely ignores advanced acoustic countermeasures, turning complex littoral waters into a dead end for intruders. On paper, this is the ultimate sub-hunting combination. Before we go on, do you think this new weapon can truly secure the Atlantic, or is the fleet too small to face the threat? Subscribe to the channel to track the balance of power, and tell me where you are watching from. To comprehend the true lethality of this combination, we must first examine the first core element of the system, the Boeing P-8A Poseidon MRA1. This aircraft is not a standard military transport, but a heavily weaponized and reinforced derivative of the Boeing 737-800 ERX commercial airliner. By utilizing a commercial airframe design, the Royal Air Force benefits from high transit speeds, allowing the aircraft to reach a reported distress signal or a suspected undersea contact hundreds of miles away within minutes. This swift response time is crucial because, in modern undersea warfare, an unmonitored submarine can disappear into the vast deep ocean if it is not tracked immediately. Once the P-8A Poseidon arrives at its designated patrol zone, its primary sensory organ, the Raytheon APY10 radar system, takes complete control of the airspace. This multi-mission radar operates with exceptional maritime surveillance capabilities. In high-resolution synthetic aperture radar modes, it can isolate a tiny periscope or a mast protruding just inches above the water from extreme distances, even when surrounded by massive sea clutter and crashing waves. However, modern hull designs often remain completely submerged, which is where the internal sonobuoy launch system becomes indispensable. The P-8A Poseidon can carry and deploy an extensive inventory of active and passive multi-static sonobuoys. When dropped into the ocean in a precise pattern, these sensors form a massive, synchronized digital hearing network beneath the waves. This system intercepts acoustic signatures and calculates target coordinates with immense accuracy, stripping away the stealth advantages of ultra-quiet vessels like the Russian Yasen class, which operates at estimated noise levels below 90 decibels. Leading global defense analysts argue that on paper, this sensor suite leaves any intruding vessel entirely exposed, converting the vast North Atlantic into a transparent fishbowl. While the detection capabilities of the aircraft leave target vessels exposed, a tracker is only as good as its strike option. This brings us to the second core element of the system, the Stingray Modification 1 lightweight torpedo. This British weapon measures exactly 330 millimeters in diameter, weighs 267 kilograms, and carries a 45-kilogram high-explosive shaped charge warhead. Unlike older torpedo designs that rely on a generic blast radius, the shaped charge configuration focuses its entire explosive energy into a single concentrated stream. This force is specifically engineered to punch clean through the incredibly thick, double-hull titanium steel structures favored by modern Russian submarine designers, causing immediate catastrophic flooding. The propulsion system of the torpedo is equally advanced, relying on a magnesium-silver chloride seawater battery. The moment the weapon enters the ocean, seawater floods the internal battery compartment, triggering an immediate chemical reaction that generates massive electrical power. This current drives a specialized pump jet propulsion unit, forcing the weapon through the water at speeds exceeding 45 knots, which is more than 83 kilometers per hour. With an operational diving limit extending down to 800 meters, it can easily catch the deepest diving attack submarines in service. However, its most significant tactical advantage is its fully digital acoustic homing sonar brain developed by BAE Systems. When moving through the water, the weapon uses proprietary software algorithms to analyze the acoustic spectrum in real time. It can instantly differentiate between the actual mechanical signature of a target hull and advanced acoustic countermeasures, or deceptive decoys deployed by an enemy vessel. This specialized filtering system allows the weapon to operate with high reliability in shallow, noisy littoral waters near the coastline, areas where foreign submarines often attempt to hide from traditional sonar trackers. This integration establishes a highly responsive anti-submarine warfare solution, enabling the Royal Air Force to detect and hit undersea targets in under 5 minutes. By synchronizing this specific loadout with allies like Norway, who also utilize the weapon, NATO creates a unified defense perimeter across the North Atlantic. Furthermore, securing this sovereign supply chain allows the United Kingdom to free up its advanced Type 23 and Type 26 frigates, sending them to the Indo-Pacific region to support regional security commitments under the AUKUS partnership, without exposing the home waters to sudden intrusion. However, defense planners must still confront significant tactical vulnerabilities. While the Stingray Modification 1 torpedo provides exceptional capabilities, the United Kingdom fleet consists of just 9 P-8A Poseidon aircraft. In a prolonged conflict involving attrition or extensive maintenance cycles, this small number creates an operational bottleneck. Additionally, the P-8A airframe is based on a commercial airliner design, meaning it faces high rates of saltwater corrosion when flying low-altitude search patterns over the Atlantic. This issue requires extensive jet wash cycles and maintenance hours, which reduces the number of aircraft ready for immediate deployment. The strategic takeaway from this development is clear. True military independence in modern warfare requires nations to control both their detection platforms and their strike weapons. By pairing the American aircraft with a British weapon, London secures its defense posture against advanced quiet submarines. However, a major question remains regarding the sustainability of this specialized fleet over a long conflict. Do you believe that a technologically superior weapon like the new Torpedo can overcome a critical shortage in actual aircraft numbers? Or will the small size of the fleet eventually become an undeniable weakness during a crisis? Leave your thoughts in the comment section below.